Hi, fourth grade friends. This is lesson 12 of module 6, and we're going to be talking about applying our understanding of fraction equivalence in tenths and in hundreds. So here's our old friend, the place value grid. And this first one, if you look at it, it's been done for you. But they're looking at how the tenth is related to the hundredth. I know that I have 1/10. That is going to be equivalent to having 10 100ths. So if I transfer this guy over here, that means he's no longer in the tenths. He's now over in the hundredths. That gives me 10 plus 800ths, which is a total of 1800ths. So they want you to mark 2/10ths and 300ths on the place value, and then they want you to transfer the tenths over to the hundredths to show how many hundredths you have. In this case, I would have each one of these tenths represents 10 100. So I would have 1023. Now you can, if you want, draw 10 separate counters for them. I know that you know how to do that. I chose to write the number 10. On the bottom of this, they've given you the words and they want you to convert these addition sentences. So we have 1/10 and 200ths. It would be similar to using 1/10 and 200ths over here. I know that 1/10 is going to be equal to 10 100ths. I know that because 1 times 10 is 10. So I have 10 hundredths plus 200ths is going to be equal to 1200ths. And you're going to be making those transfers all the way through. If you look down here on number C, it says I have 8/10. Well, 8/10, each one of those eights is going to be 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to have 10, 20, 30, 40, 50, 60, 70, 80. So I'm going to have 80 hundredths right there. So I have 80 hundredths and 25 hundredths, which is actually going to give me 105 hundredths if I add those up. So you'll be doing all of the ones on that side. On the back, now we're going to start adding them. And when we add them, I want you to look at this 3/10 plus 7 hundredths, but I want it to look a little bit bigger. So I made it a little bit bigger right here. 3/10 plus 7 100ths. And they're giving you a choice of 3 ways to solve this math problem. So we'll call this the first way. The first way, we can use our place value chart. We have ones, tenths, and hundredths. And I've got 3/10 and 7 100ths. Well, I can't add 3/10 and 7 100ths because they are unlike denominators. So I'm going to have to make these tenths become hundredths. Well, how do I make the tenths become hundredths? This one's going to come over here and be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember that? It's going to be 10. This one's going to come over here, and I'm just going to make it its 10 right there. And this one's going to come over, and it's also going to be 10. So if I add those up, 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, I'm going to have 37 hundredths. That's what it's going to be. Now, I could use the place value, or I could use the area model. When I use the area model, I'm going to be doing much the same thing that we've talked about several different times as we've gone through our math. I'm going to color in 3/10. So I have 3/10 colored in, 3/10. But now I've got to get that 7 hundredths. So now I'm going to mark off. That's why I like using the graph paper, because it's real easy to mark off. And I'm going to fill in 7 hundredths. So now I know that each one of these tenths is also 10 100. So it's 10, 20, 30, 37. So it's 37 hundredths. So I could use the place value chart. I could use the area model, or I could use the more formal method that most of your families would know more likely, that they were taught in school, is I have 3/10 and I have 7 hundredths. And I know from doing my fractions unit that I need to have denominators that are in common before I can add. So let's look at 3/10. Well, I know if I take 3/10, and I know if I multiply both the top and the bottom by 10, I can get an equivalent fraction that has the correct denominator. So 3 times 10, that's going to be 30. 10 times 10, that's going to be 100. So now I know that I could replace that 3/10 with 30/100 because they're equivalent fractions. So this could become 30/100 plus 7/100, and that is equal to 37/100. So you have one way of solving it here, you have two ways of solving it there, and you have a third way of solving it right here. And on our math problem, you get to decide which way you would like to go. So I'm going to choose to multiply it by 10 because I kind of like that method. So I have 3/10 and 7/100. And we talked about how 3/10 times 10 is going to be equivalent to 30/100. And I know that 30/100 plus 7/100 is going to be equal to 37/100. But I'm not done there because in my directions right up here, it says to write my answer as a decimal. And I know that 37/100 has an equivalent decimal of 3/10 and 7/100. So my equivalent decimal is going to be 0.37. Let's look at this one right here. We have 5/10 and 40/100. Well, 5/10. I know that 5/10 times 10 is going to be 50/100. And 50/100 plus 40/100 is going to be equal to 90/100. But I'm not done there because 90/100 now has to be written as a decimal. So I know that 90/100 is actually equivalent to 0.90, which is actually equivalent to 0.9, or 0.90 and 0.9. They are equivalent. The problems just keep getting a little bit more complex. If you look right here, I have 98/100 and 7/10. Going to have to go through the same process. I'm going to keep 98/100 there, and I'm going to take 7/10, and I'm going to take 7/10, and I'm going to multiply it by 10. So now I have 70/100. And 70/100, and I'm going to add that to 98/100. So I've got 98/100 plus 70/100. Well, that's going to give me a much bigger number. It's going to give me 168/100. But I know that if I take 168, I'm going to write it right up here, 168/100, I could make a bond out of that. And let's see, I've got 100/100 plus 68/100. Oh, there goes that dog going off. Just ignore the dog. This is equal to 1, and this is equal to 68/100. So this is going to actually be equal to 1 and 68/100. But it says, once again, to write my answer as a decimal. So 1 and 68/100 is equivalent to 1 and 6/10 and 8/100. So your answer would be 1 and 68/100. And you would go through that for each one of the problems. Cameron measured 65/100 inch of rainwater on the first day of April. And on the second day of April, he measured 83/100 of rainwater. How many total inches did he How many total inches of rainwater did Cameron measure on the first 2 days of April? I'm going to have to set up a addition problem. 65/100 plus 83/100. However, I can tell you, because I have common denominators, I'm not going to have to multiply anything by 10. I'm just going to have to add them. Then I'm going to have to make sure that I go through the process of reducing them to get the decimal form, because they're looking for the decimal form. You guys try it out. If you have any questions, check in with me during office hours.